No? And this applies to both compressive and tensive. No? This is your stress, and this is your elongation. If it is hot rolled or cold rolled or high carbon steel, what we have is, of course, still a straight line, but later on it will curve. And this is your fracture, no? Or rupture strength, or ultimate strength. For the low carbon, ano to siya? This is your ultimate strength, no? So meaning the ultimate strength or the tensile strength is the maximum stress that a certain material can carry. Now, for ductile materials, it applies, no, the stress strain diagram applies for both the shape, no, the shape of the stress strain diagram applies for both compressive and tensive. However, if you also try to recall, for ductile materials, it looks something like this. Can you recall? For the stress strain diagram for ductile materials looks like this. Can you recall that?
Yes, sir.
What is this for?
Compression.
Compression, sir.
So meaning this is for
Tension.
so the behavior of brittle materials is different when the loading is tensile and different also when the loading is compressive. And brittle materials are more stronger in compressive than in tensile. Okay? So that is why we have to treat the normal stresses on the brittle material differently when it is of different type, no? Whether it is compressive, you have a different factor of safety, and when it is a tensile. Okay? So it says here, no? Brittle materials fail by fracture. Fracture, ang the most, probably the closest kanang vernacular that I can think about here is kanang mabuak siya. No, o kanang ma-fracture imong bukog, unsa na siya? Buak na, nabalik na, no? Unlike ductile materials, muinat pa to sila, dili pa dito ka buak. Okay, so just like glass, ceramics, cast iron, you will notice they will fail buak yun. Unlike ductile materials, pwede pa na sila muinat, huwag mong buhian, mubalik pa. Okay? So that is the characteristic of brittle materials. Their failure is through fracture. And that's what we use is the ultimate strength instead of the yield point. If you will recall, sa ductile materials, we are using the yield point. So, for brittle materials, we use the ultimate strength. And then, we have to separate the equation for tension and compression. So, why? Because their behavior is not the same. Brittle material are more stronger in compression than in tension. Okay? So let's go to specific examples or specific cases. First, when it is simple tension, what does it mean when it is simple tension? If this is your element, what does it mean when it is simple tension? Asa man? How about sa taas? Okay? Pwede po sa taas, but when I say simple, isa ra ka klase. Simple, pwede nga ana ra. That is simple tension. Pwede po nga, ana ra. Simple, when you say simple tension, it is not complex. Only one type of loading. Okay? That is also true for compression. If your element is like this, it should be only on one side or probably here. No? That is simple compression. Then you will notice that the third case is now not simple. Why? Because two directions. Okay? So, mura na siya clue, ana. Basta simple gani, dili na siya para sa ani. Okay. Just to recall your Moore circle, because that's a very important topic in our first exam. Okay, we have a Moore circle. Of course, we have the axis for the normal stress. Now, how about force? The first case, it is simple tension. Where is the axis of the wait, again? Now, dere, exactly here or nilapaw dere? Exactly here. Okay? That is simple tension because you will notice one side on the x-axis for this one, for kine, if it is like that, no? If it is this one, this is for the x-axis. However, if it is for this one, this is for the y-axis, kine, this part there. And the other axis is 0. Okay, that is for simple tension. How about for simple compression? Any question, class? Those who are attending online.
Wala ra, sir.
Wala ra, okay ra. So the next case, simple compression. Where is our axis of okay, our axis for the shearing. So, where? It is where? Diri na pod? Okay, so it is here. And you will notice, this side here is the compressive. This could be the x-axis or the y-axis depending on your element. No? Ana ba ang element? So this is your x-axis. And your y-axis is the opposite, 0. Or if it is this way, then this is your y-axis. And this is your x-axis. Any question? Can you see my illustration? For those who are attending online, can you see my illustration?
Yes, sir.
Yes, sir.
Okay. So, review run eh. So, I'm trying to just okay. Next, for the third case, it is normal stress in two directions with the same sign. Nasa sunod sa circle. Asa man? Dere? Na dere nakita? Ana. Now remember, all these stresses are principal stresses. By the way, for brittle materials, we treat only the principal stress. because it is either compressive or tensile. We don't care about the shearing. Okay, if that is the case, like for example, this is the bigger one. It is here. Is that correct? How about for the smaller one? Is this correct? Asa di ay? Do you follow those who are watching online? Which side? Wala. This one will move here. Dire pa yun. Okay? So, it should be here. Both are tensile for this case. For this case. Because the third case is for both tensile and compressive. So this is for tensile. Class, do you follow?
Yes, sir.
Okay. That is for this the morsure core of this element. How about the other element? Okay, it should be
Pika side, sir.
here. Okay, so these principal stresses are both compressive. One is bigger than the other. What happens if both are the same? Let us say compressive and compressive here, compressive and compressive are the same magnitude. This one are not the same magnitude. Or both tensile but the same magnitude. What will happen? Na dire sa tunga, ay mong kuan, circle. Now remember, manasat, if it is on the middle, one side is tensile, the other side is compressive. This one is either, both are compressive of the same magnitude, or both are tensile of the same magnitude. How do we represent that in the circle? So which means that it should be the same value on the axis. Okay, so for example, if both are tensile, let us say it is here, the other one is also there. Because they are of the same magnitude. So it is a point without a radius. Oh, what is the sigma y and the sigma x are of the same magnitude. What is the formula for a radius? Dili, katong sa atong kuan. Square root of sigma x minus sigma y over 2 squared plus tau xy squared. Of course, we don't have shearing. Zero ni. The same magnitude. What is our radius? Okay? Okay na ta. So, now how do we treat this? Let's look at the first, second, and third case. Now, of course, for simple tension, it's only one. For brittle materials, you will notice that it's similar to atong ductile materials. Yield point over the, but this time, instead of the yield point, we use ultimate. And then, since it is a brittle material, the stress concentration factor is very important because the failure is not yielding. Muditso ram sa kabuak, so important kayo ang stress concentration factor. That is why we have to include the stress concentration factor. This is for tension. Remember, the tension and the compression are different ultimate strength. So, ultimate in tension, K, the maximum or the stress, kaya na raman eh. Simple one. So, it is this one. The stress in tension. So we have to use the stress concentration factor. Now for the second one, it is compressive. So ana ra siya. This time, this is the compressive stress. However, the ultimate strength for compression is different from the ultimate strength in tension. So that is why you have, if it is in compression, you have to use ultimate strength in compression. If it is tension, ultimate strength in tension. Okay, that is for case A and B. Now, for the third case, according to the third case, what you're going to do is, you are going to use whichever is larger. Remember, there are two with the same sign. It's either both are compressive or both are tensile. Ano ni siya? O this one or this one. Both are compressive and both are tensile. So what we do here is, we choose the larger. If it is compressive, kini, mas dako pa siya ani. If it is tensile, kani siya, mas dako pa siya kaysa ani. So, if it is tensile, then ultimate in tensile. No, this is a general formula. If it is tensile, both are in tensile stress in both direction, the same sign man ng tensile stress in both direction. Then, ultimate in tension over K, the larger tensile strength. The larger. Okay, so that's also true for compression. So for compression, ultimate in compression over K, the larger compression. Okay, for example, how will this look like? For example, kani. Asa man ang atong kuan? Kini. Atong. We still go back to the more circle. Where is our axis of the shearing axis? Na dire. Dire? Tapos dire? Wala pa siya dire. Okay. Are you following those who are online?
Yes, sir.
Okay. So, meaning that this stress is this one. And this is the larger. So, of course, you use this one. Use this. Now, remember, for brittle materials, we always use the principal stress. So, that is why you will notice nga ang naara gyud diri nga mga stresses ang atong gigamit sa atong factor of safety. Wala ta nagamit atong diri napita, no? In fact, ang shearing wala. How about this one? What is that case? Where is our axis now? Where is our axis now? So the axis of is somewhere here, and this is now our larger compressive stress, and this is the smaller one, and we are going to use this. So I hope you understand this. This applies for both compressive. If this is for compressive, then ultimate and compressive, larger compressive. If this is in tensile, ultimate in tensile, larger in tensile. Okay, that's for the same sign. Now, what happened now if it is of opposite sign? According to the fourth case, when it is of opposite sign, you have to treat it individually. According to this, it is necessary to have a separate equation for the factor of safety of tension and the factor of safety in compression. So meaning, you treat the compressive and the tensile. Remember, opposite sign, meaning one is compressive and one is tensile. Any of these could be bigger, any of these could be smaller. As long as they are now opposite in sign, so that is the fourth case. So we have this. Okay? Now, we have to. You will notice this is a familiar equation. Katong sa atong ductile material, 1 over factor of safety. That is why I am using this form. No? So it's average over the ultimate plus K range over the endurance. Diba anak mo to? This is for the steady or average load, and this is for the range or the fluctuating or the alternating load. Gibahin silang duha. That is also true for brittle materials. This is for tension, and this is for compression. No? Because again, for brittle materials, we separate. Because the behavior in compressive stress and compressive load is different from the behavior in tensile load of brittle materials. So, dili na ta na marato na nga formula kay gamay ra kay nagligas. No? Dali ra kay nahinumduman. Okay. Any question for those who are joining the class online? Any question? Okay, so example. Of course, our Mohr circle, one of the principal stress is compressive and the other principal stress is tensile because they are opposite sign. So our axis of the shearing axis should be inside. Should be inside, so that one side is tensile, the other side is compressive. Tensile and the other side is compressive. Because remember, opposite sign man ang atong kuan sa element. Now, in this case, it doesn't matter which one is bigger. Because you treat it one by one. Now, for sigma 1, it is always on the right. You will notice, in the Mohr circle, sigma 1 is always on the right. And sigma 2 is always on the left. Principal stress sigma 2 is always on the left. Sigma 1 is always on the right. So, for the ultimate intention, the load intention, the stress intention sigma 1, principal stress intention is sigma 1. Then you have K sigma 1 over ultimate intention. If it is principal stress in compression, then we have K sigma 2 over ultimate in compression is equal to 1 over the factor of safety. Okay, so mura na siya. Basically, this is the general formula. This is general formula. Because if you only have compression, then it is only this one without this. If you only have tension, it is only this one without this. Diba? Mao man na siya dito sa formula. If you have both the same sign, you just choose which one is bigger. Huh? And all of these are principal stresses. Again, all of these are principal stress. Now, what happened if it's a pure shear? Now, we were talking again of brittle materials does not care about shearing because the failure is either by compressive or tensive. The basis of failure of brittle materials is either by compressive or tensive. Okay, so what happens when it is pure shear? Okay, ako na lang i-drawing ang element na tari. That is pure shear. There are no normal stresses in any side of the element. Question is, how are we going to use this? Because we're not interested of the shear, but we are interested of the principal stresses. So what we do is, we look at an orientation where we get the principal stresses. Okay? How do we draw the Mohr circle for this one? Okay, so it is here. And this is your, let us just say, sigma xy. And this is also your sigma xy. And this is your sigma xy. It's also your sigma xy. What we're interested in is not this one, but this. Sigma 1. Again, on the right is always sigma 1. On the left is sigma 2. So that is what we're going to use. Now, according to this case, what we do is, we determine the sigma 1 and sigma 2. And it is easy. Because the radius is tau xy. So tau xy is also sigma 1 and also by the way, we place negative sigma 2. Because sigma 2 here is negative. Has a sign already of negative. So it will be equal to sigma 1. We place negative sigma 2. No? Because sigma 2 already has a negative sign. So that is the case. And then, after that, solve using this one. We already know sigma 1 and sigma 2. They are equal. Mora. Once there's a presence of ultimate and compressive, you always use the fourth case. As again, as a general rule, you just look at this. Tensile component, compressive component. If one is not there, then do not include that in the equation. If both are there but in the same sign, then of course, if both are compressive, so sa may mo, kay wala may tensile, sa may butang diri at katong gamay. So you choose the bigger, the larger. If both are tensile, and there are two values of the tensile, nya kinira yung may equation, wala na ni siya, so may compressive. So, sa may butang dire, dili katong gamay nga tensile. The bigger, okay? So basically, this one sort of summarizes, no? How that's ano na siya? Simple common sense. This formula summarizes everything, no? Just simple common sense. So mo ni siya kini katong kuan kini para ang pure shear. Any question? For those who are attending online, do you have any question? So idea here, if I'm going to try to summarize, the idea here is that you have to determine the principal stress and use that in the formula. Principal stress ni tanan, if you will notice, katong tanan atong kuan deregyo na siya, nato gipangita. And then apply it to this one. Okay, for those who are attending online, any question? Do I accept that silence is yes? No question?
Nakoy question, sir.
I'll go.
Nganong naay kay sa formula, sir? Nya kaning sa PDF, sir, kay walay kay.
There is another one. There is another one in the PDF na naay kay. You look at another. Because stress concentration factor is always used when you have brittle materials. You try to scan the other. Sa akong tanaw. Okay. Are you still there? I'm going to share the. I'm going to share the. Who asked that question?
Ako, sir.
Are you still listening? Okay, sige. I'm going to share the. That's one problem with. Can you see it now?
Popcorn ba? Ito, nakuha.
Can you see it now?
Yes, sir.
You're talking about this formula? You're talking about that formula?
Katong unang formulas pa, sir. Katong sa tension o compression.
Kini.
Yes, sir.
Yara, oh. Do you see that? Kanang gi-highlight nako.
Yes, sir.
So muna siya naagyo na siya K unta. Wala ra gi butang. K is always on the kanang imong actual or working stress. In fact, there is a kuan also the here. Wala po na K kini ako ang gi-highlight. Can you see the one I'm showing without K?
Yes, sir.
Okay. And then it says here, you have to apply the stress concentration factor. And we will look at this problem. You will notice, oh. Our next problem is, I think this one. The problem that we will have on the board is this.
I have 3 options though. Technically 2. Where are you?
Okay? So, in the PDF file, wala gibutang ang K. But actually, in his solution, ibutang ang K. Okay, we will proceed now. We will proceed with the solution. As of now, we will try to look at the solution. Okay? Kinsa man to
Yes, sir.
Okay, sige, let's proceed. Oh, sorry. Ako na tong nakuan. Na-stop sharing na nako. Makita na ninyo ang board? Wala pa.
Yes.
Yes, sir.
Makita
Good na
ng
pa.
board, sir.
Okay, sige. So let's look at an example here. This one is the same as the problem there. It says here that the stress at a point in a cast iron body are as follows. Okay? Your normal stress in the x direction is 14 megapascals, pencil, because it's positive. And on the y direction, your normal stress on the y direction is compressive because it is negative 42. And of course, your tau xy is 21 megapascals. So again, it did not mention whether it's clockwise or counterclockwise. We can presume it any, no? Because it will give us the same answer. So we presume that to be clockwise. And then you also have ultimate in tension and ultimate in compression. Again, they have different values. No? You will notice that the compressive has a very high. Again, the sign is carried negative because it's compressive, no? And the ultimate is positive. You are going to find the factor of safety. So if we draw the element, then we have on the x direction it's only 14 pencil. On the y direction it is negative 42 compressive. And then of course our tau xy we presume it to be for the x, we presume it to rotate counterclockwise. So nasa dire, no? Now if we draw the Mohr circle for the x, this is our x axis, and this is our y axis. 14 and 21. We presume again 21 to be in the clockwise direction. Okay, if it will be opposite, dire ra magyapon and what we're interested are this. So wala na siya kaso. Do you follow? Do you follow? Because it is not mentioned here whether this shearing stress would tend to rotate your element clockwise or counterclockwise. So if it will tend to rotate it clockwise, nasa dire, the other one is there. This will be our Mohr circle. And these are our sigma 1 and sigma 2. If it tends to rotate counterclockwise, then our point will be here, and the other one is here. You will still have the same Mohr circle, and you will still have the same sigma 1 and sigma 2. Okay, class? Do you follow? Do you follow, class?
Yes, sir.
Okay. So now, we now have a Mohr circle. So again, for ease, we just complete the center and the radius. Okay? Center is, of course, the center is sum of these two divided by 2, diba? Okay, but be sure to consider the sign. Okay, 14 plus negative 42. Okay, over 2. Then, our center is negative 14, 0. Or, on the normal stress, its value is compressive of 14 megapascals. Now, the radius, square root of sigma x minus sigma y over 2 plus tau xy. So you have to include again the sign, and we will have here 35 megapascals. So we have to compute for this one, because again, as I have mentioned earlier, what is important for brittle materials is that you know the principal stresses, because that's only the basis of our working stress, principal ra. So we have to compute for sigma 1 and sigma 2. And you will notice that they are opposite in sign. Okay, so for sigma 1, it is center plus radius. For sigma 2, it is center minus radius. Okay. Sigma 1, center plus radius. By the way, the radius is always positive, always positive because it is a distance from the center anywhere in any direction man dyan. So, center plus radius, that is for the right side. Center minus radius, that is for the left side. Then we will have this. And then we substitute it to this one. You will notice na K sigma 1, K sigma 2 over ultimate in tension, ultimate in compression. And then we will get this value. Going back to the PDF, do you understand? Atong sa PDF ba? Iyang gi-compute ang K sigma 1 o K sigma 2 dito. Did you follow? Isa naman to. Nara, K sigma 1 and K sigma 2. Yang gi-compute. Can you see the screen I'm sharing?
Yes, sir.
Oh, na yung K sigma 1. Wala na siya sa formula pero yang gibutang in the problem. Because stress concentration factors are always applied when it is in brittle materials. Yeah, muna na siya dire, continue niya. This is now the K sigma 1 and then this K sigma 2, 1 over the factor of safety. Do you follow? Kini ba? Are you following? Ay, sorry. Dili na mo kini dai. We are kini ang masayo na sabto ni. Kini dai. K sigma 1 is 42. K sigma ano sigma 1 mong gyapon ni. This is K sigma 2 ini. No? K sigma 1 and K sigma 2. Misprint ra tingali ni sigma 2 ni siya. Are you following?
Yes, sir.
Oh, ano na siya. So, K sigma 1 plus K sigma 2 over ultimate in tension, ultimate in compression, 1 over the factor of safety. So, yang kuan is only 1 decimal place. Ang ato, I've included 7 significant figures. So that's why in the summary in all my lectures I always summarize, I always include now the K. For ductile materials, if there is no K that is given, do not use it. And even if there is a K, as long as it is steady, do you recall? Ang K, magamit ra siya sa
Reversing.
alternating. Reversing and alternating. Ang alternating ra gyud kay ang steady component ana wala man na si K. Okay, but for brittle, okay na, do you now I try to modify the formula so that you can understand it and remember it easily. Okay na ta, ano yung akong i-share nga kuan? We'll go back to the board. Ha?
Yes, sir. Okay, sir.
Okay na, sige. So, 2.1 ratong iya ato, 2.1 we included 7 significant figures. So, what if the loading for brittle materials is fluctuating? Okay? Of course, brittle materials are very poor in fluctuating loads. So that's why it is always considered unsatisfactory. Unless you use very, very high factor of safety. You try, dali ra kayo like for example, the choke. So, the choke, it is easy to break it nga anahon nimo. Imo na siyang ikuan. Or even cast iron, no? Sulay ang cast iron. Baugo mo ng choke, dali siya ka mapulol. Pero imo iduot, dili siya dali. No? Compressive man na siya. Now, if you are bending it, you have tensile and compressive because it is already a flexure. So it will fail on the tensile side. Ang bawog di man ato siya dito sa tensile, mabawog. Maputol. Okay? So, any questions?
Yes, sir. Excuse me, sir.
Yes, go ahead.
Regarding sa kanang more circle, sir, ba kay kanang ngano gani sir ang diameter sir kay nagpain-ana siya sir bali nagpa right to left sir.
Which one? You're talking to this one?
Ang kanang 1421 sir.
Okay. This one.
Oh.
The coordinates of the Mohr circle is from the center, from the origin, 14. Do you follow?
Yes, sir.
And then we presume it to be rotating it clockwise, so we place it up. Do you follow?
Yes, sir.
If it is down, then this will be counterclockwise. It did not say or specify in the problem. However, if you assume an opposite direction, a counterclockwise direction, asya dire, you will still have the same Mohr circle, except that your axis will now be x dire, y dito. Do you follow?
Sir, ang x, asa tong x sir? Napita kon?
Here, sigma x. What are the coordinates of sigma x? 14 and 21.
Yes, sir.
Oh, so sigma x. How do you? This is your origin. So positive 14 and clockwise 21. Do you follow?
Yes, sir.
Oh. Now let's go to the y. This is the origin, negative 42. This is negative 42. And then, this time it is counterclockwise. Counterclockwise, the same magnitude 21. Do you follow?
Yes, sir. Bali mag-assume ra day ka sir if ang clockwise sir kay positive sir. Mag-assume ra ka sir.
For this case, it doesn't matter. Because what you're interested is this one and this one. So your Moore circle will still be the same.
For dessert, I'm sorry about storming out before I let my emotions get the best of me. Look, I know nothing ever happened between us, but I was confused about who I was.
Are you satisfied with my... Because if you presume this to be that direction, mora mo yapon imong Moore circle.
I guess Jessica was where
Yes, sir. Sabot ka, sir. Thank you, sir.
Oh. Unless, no? Unless I'm going to give the element.
Help me realize who I am.
For example, I'm going to give the element and draw the Moore circle. Of course, wala na siya. Di na ka pwede maka-assume nga kuan kay na naman ang direction sa imong tau sigma y. Tau xy.
Do you know where Jessica is? I have to explain things to her as well. There's a bar she goes to sometimes when she's feeling low.
Okay na? Any more question?
Buy you a drink?
Now, stress concentration factors are important when you have a brittle material and alternating. Ductile material but alternating load. Just like our example o katong alambre. Okay na? Wala na yung question?
Once the light circle goes away, diffuse. Use this to scare your teammates. How to defuse with 0.01 seconds left every time.
Wala na lagay, sir.
So for those, especially katong ni-ask of the question about the formula katong walay K, I'm trying to present the formula in a simpler form. Aron sayon hinumduman. Atong 1 over the factor of safety, K sigma 1 over ultimate intention, K sigma 2 over ultimate incompression. Because these are all, kuan man ni sila tanan. Dali ra man hinumduman. Diba?
Yes, sir. Nag-gets ra, sir.
Oh, dali ra ni sila hinumduman atong kuano ni isulat bisan pag piyongan ni mo ron dayon makabalo na ka. If it is ductile, 1 over the factor of safety equal to average over ultimate plus K range over endurance. If it is, this is at, asa ito nga point? H? E. E ni?
Yes,
Yes,
sir.
sir. Yes, sir.
Tanawa, if it is at H, 1 over the factor of safety, average, K range, yun point ra. Ang imong butang diri sa ilalom. If it is brittle materials, mo gihapon 1 over the factor of safety, K ultimate intention over ultimate intention plus K incompression over ultimate incompression. So naay pattern. Kinahanglan pa ba na nato kodiguhan? If you go through the textbook, dili ngon ana pagka-present, no? So murag mas I'm trying to make it simpler. So that it will stick, no? It will stick to our minds. Nga mo na siya. So, for example, simple tension ra. So, wala. Simple tension. Ang atong loading, steady. So, wala ning kanang fluctuating component. Kanira. So, unsa tong imong tension over ultimate. Yield point yield point ang gigamit adto, no? Yield point ang gigamit adto. Kini day ang kuan adto. No? Ang gamit nato sa kuan, di ba? When it is ano ba? Ana? Yield point. So kini na ito. No? If there is no kuan, kini mo kini siya. At H ni, no? At H. Dili ra na ko eresyon ng uban na ipagsulat-sulat nako. Okay, sige. So you take your screenshot. Kamo, picture mo no ay. Ha? Ano na? Ako man ipa-erase? Oo, sige. Okay na class? Have you done your screenshot?
Kina sir katanong po.
Okay, let's go to the other board. Before we say goodbye, I'm going to again make a screenshot so you turn on your cameras. Turn on your cameras, please. Turn on your cameras. Okay, so see you class, no? Can I ask you to ayaw mo hilab din ang camera ha? Okay, mag-adjust na po ko ano. Isod kayo ipasintro ng camera. Okay, class. Okay na ta, class. Okay, sige, thank you also for a successful lecture for this afternoon. Sige, bye-bye.
Thank you, sir.
You're welcome. You're welcome.
Goodbye.